Chapter 14 does start off by graphing. So we're going to do sine and cosine today. We're going to do tangent tomorrow, and then 14.2 is more graphing as well. So it's only 2 sections of graphing. However, it will take us the majority of the week to do those 2 sections. So we're going to start off just by graphing sine, and we're going to graph a ton of points this first time through, just so we can see what this function is supposed to look like. And then we'll really simplify that so we don't have to be graphing as many points each time. Let's start off here. We all have our unit circles out. We're going to be using those. Notice that it says these are all in radians. So I have the sine of some angle here in radians. So I'm going to pick angles that are on our unit circle so we can use that to figure out what the sine of those angles are. So let's start with 0. And then I'm just going to go around the unit circle. So our next angle would be pi over 6, and then pi over 4, and then pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. We'll start off with those angles. Okay, so grab your unit circle. And first of all, look at your equations. Sine is what over what? Y over r. And r is 1 in the case of our unit circle. So really we just have y. Sine is the y coordinate. Okay, so find 0 radians and put your finger on it. And I'm going to have you do this for each one, and you're going to think that I'm silly and crazy, but I want us all be in the same spot so I know you know what I'm talking about. Find 0 radians and put your finger on it. Find the y coordinate at 0 radians. The y coordinate is 0. Okay, find pi over 6 and put your finger on it. The y coordinate at pi over 6 is 1/2. Find pi over 4. The y coordinate at pi over 4 is, okay, and we're going to be graphing that, so I don't know what the square root of 2 over 2 is, so let's calculate that. Let's do square root of 2 divided by 2 in our calculator so we can put it in decimal form. And it's 0.707, right? Does that sound right? Yep. Okay, find pi over 3. Find the y coordinate. You should get the square root of 3 over 2 and then plug it in your calculator. And is it 0.866? Okay, you keep going with each of these angles then. Okay, so correct me if I'm wrong on any of those. Check yours. And then we're going to put these points on our graph here. So let's all do this the same way so that we leave room. We're actually going to end up going out to 2 pi. So let's make 2 pi the end of our x-axis here, and then we'll split it up. So if 2 pi is all the way over, 1 pi would be halfway. Pi over 2 would be half of that. Pi over 4 would be half of that. We can also put in 3 pi over 4 then. Okay, and then let's put in these other angles here. So I'm going to do pi over 6 and pi over 3, 2 pi over 3, and 5 pi over 6, just with little marks. I'm not going to put in the angles because it's too small. But before you do that, I want you to look at your unit circle. And let's just look at pi over 6 to begin with. Is pi over 6 closer to 0 or pi over 4 on your unit circle? Closer to pi over 4. Okay, it's 30 degrees from 0, where it's only 15 degrees from pi over 4. So when we put in this little tick mark, we don't want it to be halfway in the middle like all the rest of them have. We're just going to put it kind of close to that pi over 4 on both sides. And mine's off a little bit. But same with the 3 pi over 4, we'd have those little red tick marks a little closer to 3 pi over 4 than to pi over 2 or pi. And then as we look at our y coordinates now, we did the sine of all these angles. We got these decimals in here. What's the largest of any of these numbers? 1. Now think about your unit circle, right? We said that sine always had to be between 1, because we're talking y coordinates, and -1 on our unit circle, right? And so when we're graphing these, it's going to follow the same thing. Can't ever go higher than 1 or lower than -1. And we could maybe put in a few tick marks in between. I'm going to call that 1/2. And that would be 1/4 and 3/4. So you take some time right now and graph each of those points that we have. What do those points look like when you put them all together? Looks like a parabola. It's not, so don't connect them yet. We haven't gone far enough around our circle. So we're not going to put all of the points in the rest of the circle, but let's continue with a few more points here. Let's pick, what do we want to do? Let's do 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi, just to add on some more points there. So you find each of those angles on your unit circle, and then find the y coordinate attached to it. Okay, so let's just kind of go through this together and make sure we're all in the same spot. So 5 pi over 4, if you go to that angle, you again have to correct me if I'm wrong on any of these, you guys. Negative square root of 2 over 2, which is negative 0.7 approximately. 3 pi over 2 has a y coordinate of -1. 7 pi over 4, negative square root of 2 over 2 again. 2 pi, now we're at a y coordinate of 0. Okay, so on my graph over here, I just kind of filled in. I put 3 pi over 2 here in the middle of pi and 2 pi, and I split it up kind of like we did in the middle of 0 to pi. And so if we graph those, it looks something like this, which instead of just being a parabola, is actually going to have this wave shape. This function is called a periodic function. I don't think you've ever graphed anything like this before, where this cycle will continue. Okay, if we pick this up, and now we know we could count angles around our unit circle as many times as we wanted, right? We counted around once, but we could keep going, and that would just give us bigger angles and bigger angles. But what would happen if we did that is this that we just graphed would just keep continuing. That's called one cycle. I could go the same way over here. That same shape, if I go into the negative angles, is just going to continue. Okay, so let's do a few of those negative angles just so we can see that same shape. Again, we're not going to graph as many as we did on the top of this, but let's just pick a few angles here. Let's do negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. And let's do these together because a lot of times we get confused on the negative angles. Yeah, add a slide on if you need to. No, don't use the next one that's on there, but add a page in if you need to. Or if you have room, that's fine too. Okay, find negative pi over 2 on your unit circle. Put your finger on it. Everybody do that so I know we're all at the same spot. Find negative pi over 2 on your unit circle. Put your finger on it. So we should all be at the bottom, right? Because we're counting the opposite direction. So we have a y-coordinate there of -1, okay? Find negative pi. Put your finger on it. Now we should be on the left side, right? So you have a y-coordinate of 0. Keep going. So we don't have to split our graph up into as many tick marks here because we don't have as many points to graph. But if we go the same distance to the left, here's our -2 pi. Split that in half, that's -pi. Split that in half, we have -pi over 2. And then halfway between -pi and -2 pi is -3 pi over 2. And then you can graph those points. Now we don't have as many points here, but if we know that this same pattern continues, if my graph was 100% accurate, that should match. Now it's not, but that's okay. We know that it follows that same pattern, so it's going to look like this. And we do want arrows on both ends showing that that pattern continues. Okay, now like I said, when we graph this in the future, all of the sine graphs are going to look like this one. What's going to change is our x-axis and our y-axis. This is 2 cycles. That's 1 cycle here, and that's 1 cycle here. And each time we graph, we're going to graph those 2 cycles. So we just need to adjust our y-axis and our x-axis to figure that out. We're not going to graph all of these points. We're going to graph the important points so we can see the shape. And the important points would be the x-intercepts, and the max and min. We don't really need the rest of it if we know what the shape of it looks like. Okay? So how are we going to find that? Well, we'll do that in these next slides here. So this one, we're going to graph 2 times the sine of x. So it should have the same shape again. That 2 is just going to make a little adjustment on it. Let's pick these angles. -2 pi, -3 pi over 2, -pi, -pi over 2, 0, and then the positives of those. Okay, let's do a couple of these together. So let's just start with 0 here. So I'm going to plug in 0 for my x. Now, how this equation is written, we need to do the sine of 0 first, and then we need to multiply it by 2. So find 0 on your unit circle. You're doing sine, which is the y coordinate, and that's 0 in this case. And then we're going to multiply that by 2. So we have 0. Okay, we're going to do the same thing. Let's just go with our positives here. We're going to find pi over 2 on our unit circle. Put your finger on it. Find the y coordinate at pi over 2. And multiply it by 2. So the y coordinate there is 1 times 2 is 2. You keep going. Nope, when it's negative, you still multiply it by 2. So, like, for example, this one would be 2 times the sine of negative 3 pi over 2. So you'd find that. Sine of negative 3 pi over 2 would be 1. And then you multiply that by 2. When you do go to graph this, we just need to go to 2 pi and negative 2 pi, and you don't need to break it up in any more tick marks than what we have for points here. So I'm going to put pi and pi over 2 and 3 pi over 2. And the last graph, though, we went from 1 to negative 1. What are we doing on our y-axis this time? 2 and negative 2, yep. Okay, so again, each of these represents one cycle here. So as I move this, if mine was perfect, if I had graphing paper, they would match up exactly. And I could continue that to the right or the left. So right now we have 2 cycles here for this graph, and that's what you're going to be asked to do today. One cycle, this part that I'm moving around in blue here, the horizontal length of that, so from here to here, that's called the period. So for this graph, that's an R there. For this graph, the period is 2 pi. And so what we're going to be thinking about each time is breaking that period up into these chunks, these sections, so that we get our x-intercepts and our max and our min. Okay, so this we really broke up into 1, 2, 3, 4 different sections. And so if I divide that number by 4, that gives me 2 pi over 4, which I can simplify to pi over 2. And this is what my first tick mark is going to be. And we'll talk a lot more about that with the following graphs here. But our first tick mark was pi over 2. That's what we end up counting by. The vertical distance, so as I think this way, half of that vertical distance, so from 0 to 2, that's called the amplitude. It's the distance from the center of the graph to the max, or the center of the graph to the minimum. And that is denoted by the letter A. Why is that 2 in this graph? Because you're taking it times 2, exactly. This is A right here. And so in the previous graph that we did, the one with all these points, the amplitude was from here down was 1 in this case because we didn't have a number in front of the sine of x. This is just 1 times the sine of x. So whatever that number in the front is, that's going to affect your vertical distance. Okay. Every sine graph that you do is going to look like this. Every single one. So some characteristics of sine is that it's going to start, I call it the starting value, but it's going to have an x-intercept of 0, 0. When your x value is 0, your y value is going to be 0. From there, it's always going to go up. Okay, and so some different characteristics that you need to remember with sine and what's just going to help you to graph overall. If you can picture what this thing is going to look like, it's going to be a piece of cake. All right, let's talk about cosine. So we're not going to go back and graph all of those angles again. We're going to stick with those same major points, our maxes, our mins, our x-intercepts. So let's do the same values that we used last time. And let's do a few of these together. So let's start with 0 again. So point to 0 radians on your unit circle. And is cosine the y coordinate? No, cosine is the x coordinate. So now we're switching gears here a little bit. We're looking at the x coordinates because we're talking about cosine. So the x coordinate at 0 radians is 1. Okay, pi over 2. X coordinate at pi over 2 is 0. Pi. X coordinate is -1. You keep going. Okay, so every cosine graph that you guys do is going to look like this one. And you decide what it looks like. I've heard some people call it a W before. Looks kind of like a W. Characteristics of cosine on the y-axis here, you're going to have the point 0, 1, or it's actually going to be 0a. And a stands for the same thing in cosine as it does for in sine. It's your coefficient. So that's 1 times the cosine of x, which is why it's 0, 1 in this case. And from there, it's going to go down. Okay? You have the same thing as sine where if I took one cycle, so I took this part right here, if my graph was 100% accurate, if I moved that, it should repeat exactly. Now mine's not even close, but if I had graph paper here, it should match. And you don't have to just take that one piece. We always kind of think that we start at 0 and we take that piece, but I could really start here And this is also one cycle. So if I took that piece in red and I moved it over, it should match. If I move it over here, it should match if I continued my graph on. So it doesn't always have to start at 0 where you think of your cycle being. Eric? Oh, thank you. 2 pi should be positive 1. Yeah, if you see any other mistakes along the way, let me know. So the green and the red here, we call that one cycle. It also has a period, that's the length from horizontal length. And so this would also have a period of 2 pi for cosine. And just like with the red and the green, when I moved that around, I can move this around too. That's one cycle. That's one cycle. And my graph isn't accurate, like I said, but we should be able to pick any piece there, any chunk, and say that that horizontal distance gives us a period of 2 pi. All right, let's do the next one here. Let's pick some of the same points. Let's start here at 0 in the middle. And let's just do a couple of these points. So let's do pi over 2 and pi, and let's see where we're at here. So this one's different because the 2 is in the middle with the x, where when we did the sine a couple slides back, the 2 was in the front. So this 2 is going to do something different. So let's do cosine of 2 times 0. Now when we do this, we have to do the 2 times the angle measure first. You can think about it as being parentheses in there. So 2 times 0 would be 0. We're going to do the cosine of 0. Okay, so find 0 on your unit circle. And the cosine, the x-coordinate at 0, is 1. Okay, so let's do the next one. We have the cosine of 2 times pi over 2. What's 2 times pi over 2? Pi, because it's 2 pi over 2, right, which simplifies to 1 pi. So find pi on your unit circle. The x-coordinate at pi is -1. Okay, let's do pi. So cosine of 2 times pi. 2 times pi is 2 pi, so find 2 pi. And the x-coordinate at 2 pi is 1. So we have a problem here, because we're finding the maxes and the mins, but what about the x-intercepts? We need those in the middle, right? So let's pick some angles that are in the middle of each of these. Let's do pi over 4 and 3 pi over 4. And I'll let you guys go back and do those, but let's do the negatives of all of those too. So let's do negative pi over 4, negative pi over 2, negative 3 pi over 4, and negative pi. And let's maybe just do one of these blue ones together. So in between here, I have the cosine of 2 times pi over 4. Which gives us 2 pi over 4, which is the same as pi over 2. So find pi over 2, and the cosine of pi over 2, the x-coordinate at pi over 2 is 0. The x-coordinate at pi over 2 is 0. So that's what we were looking for, is that 0, that x-intercept. Okay, so you keep going, you fill those in. Okay, so check yours, check mine, and make sure mine's right too. On this one, we don't have to go out as far. We're going to stop there from negative pi to pi. So let's do pi here and negative pi. And then we can split those up. Pi over 2, pi over 4, and 3 pi over 4. Anyone have questions on the shape of this one? Still that same W shape, right? Still has a point here of 0, A, where A is 1. And then from there, as you go to the right, it goes down. So that's what cosine looks like. Now the question is, this looks exactly like the graph that we had last time in the last slide. Same shape, right? But in this one, that was just the cosine of x. It went out to 2 pi and to negative 2 pi. In the one that we just graphed, it only went out to pi and negative pi to have that same shape. How do we figure that out? So there's an equation for the period, and this goes for sine and cosine. And this is something you absolutely have to know. Highlight, underline, star, whatever it is. The equation is going to be 2 pi over b. Now we already talked about a, so we have an equation that's a times the, I'm just going to write in cosine here for this one, of bx, where b is the number coming before that angle. So in this equation, b was 2. And so if we plug it in, if we have 2 for this example here, we have 2 pi divided by 2. That simplifies to pi. And that's equal to the period. That's the length of one cycle. So from here to here. And what we're looking for in each of our graphs is to have 2 of these cycles to make it super easy for us to graph. So we find that pi, that period, and then we divide it into 4 because we want 4 different parts here so that we can get our max, our min, and our x-intercepts in the middle. And we'll go through another example of that in a little bit. Okay, I'll show you that again. Let's just quick talk about some of these characteristics again. So sine and cosine have similar characteristics in a lot of ways. Domain is going to be all real. So domain stands for x, right? And x is an angle measure in each of these equations. So like we talked about before, we really only went around our circle once, or this last time like half of a time. But we could continue going around, think coterminal angles, as many times as we wanted. So that would mean it would go to the right and to the left a whole lot further as we graphed out. Our range is in a standard graph from 1 to negative 1. But if we put a number in front of our equation like this one, with that 2 there, now it's going to go from 2 to negative 2. And that would change with whatever that a value is. Amplitude is the absolute value of a. So in some equations, you might have a negative 2 sine of x. The amplitude is still 2. It's always positive because you're talking about a distance. The amplitude is the positive value of A. Each function is periodic, meaning that if we pick it up and move it, it would just continue repeating. The shortest repeating portion is called a cycle. That's a vocab word that you need to know. When I say cycle, that means one part, that if we picked it up, it would repeat. And then the length of that cycle is called a period. And again, that's something you need to know. The book gives us this equation here, 2 pi over the absolute value of b. I wouldn't really worry about the absolute value. I don't think any of the graphs in the book have a negative b value. We could, but nothing that we're going to graph will. So let's just worry about the 2 pi over b. And that's that equation that you need to know. Okay, so just kind of visually, what are we doing here? This right now is on a sine function. It has a y-intercept of 0. It goes up after that and has this wave pattern. If I increase my a value, so again, a times the sine of x, there's that amplitude increasing, or vertical distance. If I increase b, look what happens. The cycles keep getting shorter as I increase b. So we have more of those cycles happening in the same horizontal distance. Okay, and then if I make this 0.5 instead of 1, now you're only going to have half of that many. Cosine, now we're starting up at 0a, 0, 1, this would just be a regular cosine of x graph. As I increase a, same thing happens. The amplitude extends up and down. And then same thing happens as I increase b. We end up with more cycles, or as I make b smaller, we end up with less cycles. Okay. So let's graph one that has all of these different parts in it, and let's make it real nice and easy here. 4 pi times x, cosine of 4 pi times x. Okay, so first thing we want to do is graph the parent function. We just want to know what it looks like. So we're going to put in 4 tick marks on each side of the y-axis. And you might want to make a note of that so when you go back and look, you're remembering that you're breaking one cycle into 4 pieces. That's going to give us all of our important parts, our x-intercepts, our max, our min. We're going to do the same thing on the other side. And then I'm just going to make 1 tick mark on the positive and 1 on the negative for the y-axis. Okay, what did cosine look like? Look like a W. Where are we on the y-axis? Are we at 0, 0, or are we up? Up. If it's sine, it's at 0, 0. If it's cosine, it's here at 0a. What did it do after that as I went to the right? Went down. So now we go down to 0, down to the negative, 0, positive. And if we continued that same pattern, it should look exactly the same over on the left side of the y-axis. So you can continue your points on. Every cosine graph that you do is going to look like this. So every time you're asked to graph cosine, you're starting with that. You don't have to use your unit circle at all at this point. Okay? Then we're going to change the scale on the x-axis to fit our new period. So this is, our period was 2 pi over b. What's b in this case? Look at your equation. 4 pi. Yep, because it's a cosine of bx. So b is 4 pi. So our period is going to be 2 pi over 4 pi. Which simplifies to what? 1/2. That is the length of one entire cycle. So this was the cycle, right? I can move that around here. So that means that this fourth tick mark over here is 1/2. And we're breaking that into 4 parts. So 1/2 divided by 4 would be the same as 1/2 times 1/4, which would be 1/8. That's my first tick mark. So this tick mark over here is 1/8. Now we're just counting by fractions, so that's easy. 1/8, this one's 2/8. But we want to simplify. So we have 1/4. The next one is 3/8. Same thing on the other side. Okay, step 3, we change the scale on our y-axis to fit our amplitude. What's a? 1, because it doesn't have a number in front of cosine. So this is 1, this is -1. How do we check to know that we're right? Here's the question. So let's pick a point anywhere on the graph. I'm going to pick this one right here. It has coordinates 1/2, 1. Okay, we're going to check to see if that works in our equation. So I'm going to put in 1/2 for my x, and I'm going to put in 1 for my y, and we're going to see if it works. Here's where you need your unit circle. 4 pi times 1/2. Don't grab your calculator. You know how to do this. 4 pi times 1/2 is what? 4 pi over 2, which simplifies to 2 pi. So you're going to do the cosine of 2 pi. Find 2 pi here in your unit circle. And the x-coordinate is 1. Okay, so that point works. And you should be able to do that with any of these points. Okay, you pick a few of them. If they work, you know you're right. We also can plug it into our calculator. So let's do that. Grab your calculator. Go to your y equals. And plug in cosine of 4 pi x. And then before you graph it, make sure you're in radians. Everybody do this with me. You need to know how to graph it on your calculator. Everybody's in radian mode, because all the angles that we're giving right now are in radians. And then if you go to your graph, it's going to look crazy. It's not going to look anything like what we just graphed. Why? It's a lot smaller. Our graph went from -1/2 to 1/2. My calculator's going from -10 to 10, so that's showing 20 times what I want it to look like. So we need to go to our window and we need to adjust so that it matches ours. So -1/2 to 1/2 on the x's. My scale, I'm counting by 1/8 each time. My y's, I'm going from -1 to 1, and I just counted by 1, so I don't need to change that. And now it should match exactly what we have. It should look exactly the same as what we just graphed. Lucas? Okay, hang on one second. Any questions on this? Okay, so long lesson, right? But you guys stuck in there. Okay, this is assignment number 1, but because you guys did such a great job today, yes, you have to write the whole thing down. All you need to do for homework tonight are those 4 problems. And they don't even involve graphing. All you need to do, I think, for all of them is find the amplitude and the period.
Thank you.